All right, so thank you for joining me basically on this session on cooling. Specifically, I'll be talking about immersion cooling and so as well some other advanced cooling options, just to discuss basically the opportunity of enabling sustainable data centers going forward, right? So allow me to 1 second. I can't see actually my own speaker screen. 1 second. This is not really small. Yeah, I think we moved on to the next slide, I guess, right? All right. So a little bit of background on Asperitas. Happy to join you guys. I'm the Chief Commercial Officer of Asperitas. I've been part of the team since 2017. My background for the last 12 or so years, I've been focused on bringing sustainable technologies to the data center industry. And ourselves, Asperitas, we have been developing technology since 2014, brought it on the market in 2017. Since then, we have received a lot of recognition for the sustainable impact our solutions can have on data centers. We'll discuss that a little bit later on as well. And as well, the most recent award we got was on data center innovation for cooling. Since our launch, we have been focused on several projects in Europe and abroad, as well in Asia, for different use cases, different type of users. All of that we'll be discussing because I think there's a great opportunity for immersion cooling to create a new landscape of data centers, and happy to discuss that with you guys today. So yeah, what are the drivers for advanced cooling in general? What we see in the market is that there's a very strong need for a higher performance. With higher performance, we basically see that as a combination of KPIs that we see that are now going up. Thermal design power from CPUs and GPUs are going dramatically up. Compared with a few years ago where 120, 150 watt per CPU and GPU was high. We see now the roadmaps of an NVIDIA and AMD and Intel going up to 400 watts per GPU or CPU, even in the next generation going up to 1,000 watt requirement. And that's quite a challenge to cool with air. Probably not impossible to a certain level, but if we look at the other elements of performance increases we see now with our users, but in the market in general, just following, for example, the Uptime Institute reports coming out on rack densities, we see a dramatic increase going from an average 5 kilowatt per rack to what's now almost an average in some regions for 20 kW. And beyond that. And that's quite a challenge. We see also the number of GPUs and CPUs going up within a server unit. So the density within a server unit is going higher. And as well, the constraint on space in general in facilities brings up quite a high density requirement on the facility end as well. All of this combined with another OEM challenge, I think we see where components need to be cooled on lower temperatures. We see that actually going down since the last few years. So the performance is going up, temperature for cooling is going down. That's a very difficult challenge to deal with from a data center perspective, especially within the rack. And that's where we see performance coming in. Especially for immersion cooling to solve that in a reliable and predictable manner. And I think that's in line with what we'll be discussing today. The other elements we see are, of course, efficiency. Again, we'll be discussing that later, but I think there's a great opportunity to look at how can we get efficiency across the whole board, not in some certain regions where the conditions are, from an environmental point of view, are almost ideal, but in any region where compute is required, then I think there's a great opportunity to create a real efficiency win. Combined with sustainability requirements, we see now getting on top of the agenda, especially from enterprise users. And with sustainability, the way we look at it, it's a broader perspective than just energy efficiency alone. We see other metrics coming in. We just finalized some research with our partner Omdia, where we looked at enterprise and cloud user requirements and how they measure sustainability. We see a set of metrics coming up, going from energy efficiency, heat reuse, water consumption, utilization, but as well circularity of materials, and of course the carbon footprint. That's quite a wide set of metrics. And again, I think immersion cooling can bring in impact that's covering several of those metrics at once. So that's another element to take in account, and a driver we see now very strong in combination with performance. And then we see another need in the market as well, with users to get compute closer to the end user, bring the application where it's being used. We used to call that edge within the industry. I think that term is going a little bit now slowly away, but I think we all see that there is a strong need in a high number of zones geographically closer to the end user. And again, this brings in other challenges, and I think there's an opportunity to look at a different model to design and operate data centers based on another advanced cooling method. Altogether, I think a great opportunity to answer those different drivers we see. I think this is the time to see if we can change that landscape and see if we can actually come up with a better model. Yeah, so in our space, what we see several kinds of users going for immersion cooling. Cloud users definitely is one of them. They look at efficiency across the board. Enterprise is definitely exploring different kinds of advanced cooling methods. Reason behind that, actually, what we see is that high performance computing becomes a more mainstream application with different type of users, including enterprise. So enterprise users going for a form of liquid cooling, including immersion cooling, we see that they have a high performance computing demand. So usually that starts at a very specific team in an organization focused on compute power and working within an environment that's not built for high performance computing. They go for a change. So we see a strong demand there. Telco edge, we use that as a combination. That's definitely one of the areas where we see a lot of opportunity for immersion cooling to solve different challenges again than the other users, cloud and enterprise. There are a lot more constraints, a lot more sites to serve, no personnel or staff specialized on site. So there's a high demand for remote control, but as well resiliency and reliability. And I think immersion cooling can provide some benefits there too. High performance computing, yeah, it's presented here as a separate user group. We actually see this demand for high performance compute applications within all of those three groups. And as well, to avoid some confusion, we see all of those users in different kind of environments. I think later in the presentation I'll cover that a little bit, but also in co-location spaces. This brings in other challenges to also not only look at single tenant or on-premise facilities, but also take into account a hybrid environment, including co-location space with advanced cooling. So very quick step forward to what immersion cooling can bring to the table. And of course, this depends on the use case, the scenario, the location, the type of user, the benchmark we're using. Later, I will show some cases to show the impact, according some benchmarks. But it's clear that immersion cooling can bring some benefits on different elements, including the energy footprint can be dramatically reduced, even if the comparison is already with a high density environment where performance was key already. We have seen cases where compared with that situation, maybe a 20 kW environment, rack density, it's already quite efficient in terms of performance, but we see that immersion cooling can easily achieve 25-30% of energy reduction compared with an high performance environment where energy efficiency has not been the optimal just yet. With immersion cooling, that can be done. Other use cases are, for example, footprint reduction. There's a great opportunity to look within immersion cooling, what's happening with the IT, and see if we can increase that density. That would allow for a lot more compute and a higher performance utilization as well of the compute within a server unit. To keep it really simple, that's an expectation we have for the market actually in the next few years, where we will see a lot more optimized environments, not just see immersion cooling as a replacement of what's now state-of-the-art traditional air cooling, but where it's being really used as an opportunity to increase the performance on basically full-time, full load performance, high temperatures, and so on. I think that's going to be quite interesting to see. The business case is, in most cases, very interesting, especially if we look at environments where already the demand is there for high rack densities. And later I'll show some clear visual on that, where we can seek the sweet spot actually to apply an advanced cooling method like immersion cooling. The last thing I would like to point out is heat reuse. That's one of the metrics we see now within the sustainability metric set with potential uses. Heat reuse is in scope. It's not yet in the top 3 of metrics, but it's definitely under exploration for most users, especially in Europe, Nordics. This is quite an interesting benefit. It's very simple. With immersion cooling, we capture all of the heat, which can be transferred on high temperatures in a medium with minimal losses. And I think that's a great advantage. It brings those use cases a little bit closer. Still, you need, of course, all of the elements together to make this work, including the demand for heat. But altogether, I think we'll see a lot more projects on that side as well. So maybe a step back on liquid cooling in general. Again, what we see is that users usually explore different types of advanced cooling methods across liquid cooling and look at all of the benefits and the exact use case they have. And that's something as well what we would advise, and where we first look at the application, what's the workload, where do you want it to be facilitated. That's the start of the advanced cooling method you will select as a user. And then there are different options within this space, and we can make a comparison with air like we see now on screen, of course. But very simply put, there's like a single phase cooling category, water cooled, direct on the chip solutions, immersion cooling in different shapes and formats. But let's use that now as one category. And there's two-phase immersion cooling as well, which has benefits on the performance end, maybe even beyond what we see now as a practical application. But the real downside there is global warming potential. We believe single-phase immersion cooling can bring the performance that's required of today and the next generation, but also take sustainability and efficiency in account. So I think there's a clear benefit on what immersion cooling can bring to the table. We see the POE, of course, going dramatically down. I can now show some cases where how does this look like if we compare this with an actual case, actually. There we go. So yeah, maybe a little bit more direct. We do immersion cooling slightly different, and we believe that's the most energy efficiency way of immersion cooling. There are no pumps involved. It's a passive system, and I can now explain a little bit how that works from a technical point of view. But altogether, that makes it a very reliable and predictable solution. And from our point of view, that's very important. It's one of the elements. We see that users who are exploring liquid cooling, they seek, basically a way of to meet their reliability requirements. That's one of the top drivers to select a liquid cooling method. However, at the same time, for most new first-time users of immersion cooling or liquid cooling in general, the reliability is also something holding them back. So that's key in all of the development we do on products to make sure that this is very consistent and reliable. So how does this work from our perspective? Again, single phase immersion cooling, and there are different way of circulation and methods within this space. So it's not one solution fits all, but what we provide is natural convection based immersion cooling where there are no pumps involved. It's a very efficient way of cooling. There's basically no active component in there. So the hot components in the system, they are driving the flow within, and this is a self-managed system. More power means more flow, precisely from the places and locations in the server where the flow is requirement. So the hot components are driving the flow. That means we don't have to bring the flow to the places where it needs to be cooled, but really we take the flow from where it's being generated. It can't be more efficient than that. There are some advantages to that as well. because we don't mix the environment of the whole, let's say, basin of fluid, dielectric fluid. We don't need to maintain one temperature to keep all of the components cool on the lowest requirement we see in the server. Could be 20 or 32 degrees Celsius. We don't need to do that. It's being self-managed, and there's like a temperature layering within the system where there can be a delta as well within a basin. That allows again for warm water cooling, which is a great advantage. In some circumstances, we have seen cases where the requirement is to cool with ambient temperatures of 48 degrees Celsius even. So that's quite a high requirement that can be done with natural convection based cooling. At the same time, natural convection is that efficient that it meets all of the thermal design power requirements we see now in the market, up to 1.5, 1.8 kW per server unit, quite high. This can be done with the natural convection based immersion cooling method. So just to look at a case, and I think we should see this as an industry as a great opportunity to see what we can do about what's still the global average PUE of today. In the last few years, it's maybe going in and out between 1.5 PUE up to 1.6 in the last 3 years, if I have to believe and follow the uptime reporting on that topic. If we take the 1.6 global average, just to keep things simple, then you can see on screen quite some benefits there. Huge energy footprint reduction, not only on the cooling side. It starts with the IT power demand. To keep the case very simple, what we don't use are fans in the server. We see an average of about 12% of IT power, so on the server side, being utilized by the fans alone. That's significant. There's a win on day one. When we apply immersion cooling in any case. So even if the facility is not optimized or the environment is not ideal, this can be still achieved on day one. And this results in, of course, a dramatically better PUE. Could be even better if we wouldn't take this IT power reduction into account. So we basically reduce the total energy footprint as a whole. So PUE is not an ideal metric, something to consider as well going forward as an industry. I think that should be more clear. It's about the total energy consumption, not alone about the efficiency within the facility. But there are some other advantages as well. Again, I would like to point out the heat reuse case, just as an inspiration for the industry to look at how can we utilize this heat in different circumstances. And our technology allows for a very high efficiency. 98% of power in leaves the system in the form of thermal energy and can be transported and utilized elsewhere. For example, district heating. I will show some other examples later on. And the last one I would like to point out is water consumption. We see, of course, very efficient power-wise environments today on other technologies as well. But in many cases, water is being used and consumed in very high volumes. With immersion cooling, that's not required. We use water, but in a closed loop system, so there's no real water consumption going on. So yeah, even beyond that case, I think there are some other benefits from a strategic point of view that immersion cooling can bring in. And again, I would like to use this as an inspiration to see if we can end up in a different kind of data center model. There's a lot more utilization of space possible with immersion cooling. If we would look at custom or tailor-made spaces for immersion cooling, we don't need the volume of a room to facilitate airflow anymore. So it can be as dense as the system itself. That's a great opportunity to bring compute in spaces where we don't have the volume or the height in a room. It's not required. There's also an advantage of looking into, I think, bringing compute to central business hubs with limited space, but a lot of demand for compute power within or next to buildings. I think this could be a great advantage. So there's another way of how we can look at combining data and energy hubs. I think that's a great opportunity, and immersion cooling make that probably slightly easier to do so. Last benefit, I think, is that with immersion cooling, you can bring in this energy efficiency we see coming from hyperscalers. Looking at the metrics they publish, I think that they are doing a great job, a lot of efficiency based on scale. But if we want to bring that energy efficiency to smaller sites or less advanced sites or geographically less ideal zones, I think immersion cooling can bring that efficiency without the hyperscale case. So this becomes in reach for enterprise and cloud users of slightly smaller scale. Yeah, again, when does this become interesting in terms of when should a user or a facility look at a technology like immersion cooling? Again, we see a lot of misconceptions there, where users tend to think that maybe from 20 kW rack density, immersion cooling becomes into play. But just to make it very simple, what we see that there's a positive business case possible from 6 to 8 kW per rack density, then it becomes very interesting to look at as well, taking into account that your IT roadmaps are going up, right? Looking at what's coming, you need to be ready. So if this is your case today, then it's really worthwhile looking into an advanced cooling method to basically prepare you for the future, but which comes actually already very close on the short term. Kaylee warned me if we're on risking if it comes to time, but otherwise I would just
we're good. Thank you, Maikel. Thank you.
All right, good. So yeah, maybe again, I think this opportunity to discuss today this method of cooling is nice to take also maybe a few side steps to see if we can look at data centers slightly different, not just look at the cooling performance. I think the time is really now to see if we can change the way we design and operate data centers. For several reasons, but one of them is basically energy play. As I said, I think there's an opportunity to see if we can push heat reuse more. There's great value in using electricity, of course, to create value on the compute and data but it leaves as a thermal energy resource that can be utilized, and it's very challenging to do that today with current methods of cooling, but again, with immersion cooling, this brings in other opportunities. For example, it brings some strategic sites, and I think site selection is increasingly a challenge, especially for large-scale operators. I think there's an appetite for utility companies to provide their locations, their sites, or access to sites when heat reuse is also very possible, I would say. Then they're a lot more likely to facilitate data centers now. Also because of local policymakers and regulations, we see definitely some strategic sites that become into reach if a combination of immersion cooling and heat reuse is being applied in an operation. And interestingly enough, those utility companies and policymakers, they tend to find us as an immersion cooling provider to connect with potential users to make it attractive to be facilitated at those sites. So if that's your appetite, then of course you know where to find us. But there are other opportunities as well. More directly, of course, when we talk about heat reuse, we have seen all kinds of pilot projects across the globe where a compute facility is being combined with a direct heat user, for example, an urban farm or a swimming pool, cases like this, which are great. If there's a match directly, then it's great for that operation. Personally, I tend to think that it would be really good if we can find a way that heat reuse can be scaled out and is not dependent on a unique case where a data center and a heat user are coincidentally or by luck or by chance at least very close in proximity to each other. Again, great cases, but it's not really, I think, the blueprint we need as an industry to go forward. But again, this is a scenario that can be easily applied. We have seen cases where a normal office building is being adapted as a data center facility with a lot of compute power based on immersion cooling with a direct user, for example, an urban farm. Those cases, from a technical point of view, are very feasible. And the last one I want to point out is that we see new regulations coming up for existing data centers and data centers that are now in construction, where in the next few years, heat reuse becomes into scope to basically to demand from those data centers. So what are the options then if you have a data center in operation based on a traditional method of cooling with low temperatures, low efficiency if it comes to energy reuse potential? Then you might consider adding on a white space that's tailored for immersion cooling to bring up temperatures, to bring up this energy efficiency for heat reuse as an add-on. And again, I think modular and prefab data centers containerized are potential solutions there. As long as they're based on immersion cooling, they can be added. And there are other options there to basically update and upgrade current facilities that are already in operation. Like that, you can meet the local demands and regulations to supply heat a little bit more easier. Just three scenarios to think about, I think, as an industry. And again, I think with traditional methods, this becomes quite challenging. I've seen cases where greenhouses and data centers are located across the street, and it's a very challenging business case. With immersion cooling, this becomes a bit more feasible. Yeah, just to mention one reference case, especially on power usage effectiveness, POE. I think we have seen a great case coming from one of our users, a French bank, which you see on screen now. They have piloted and tested and validated our immersion cooling technology over years for different kind of metrics and KPIs. And now they've decided, of course, to scale out their facilities based on energy efficiency alone. This is already worthwhile, where the current tier 4 data centers are being operated with a PUE of 1.4 all year round. They tend to be quite confident that they can achieve a 1.04 POE, a very minimal environment where it's been dedicated on immersion cooling alone. So it's a great use case for them to push forward and at the same time meet their high performance compute demands they have within the organization as well. So I think it's good to point out that what we see is that there is definitely something that's holding back users of immersion cooling or liquid cooling in general. The fact is, for most users, this is a new technology. So that means that from technology, it's new, but also from the business operation, the processes, anything, training, but it starts all with validation and testing. And with Asperitas, we have helped users basically coming over to an advanced cooling method by supporting them step by step, validating servers, offering them the KPIs to measure and test from a server to a system, and then help them with developing a scale-out plan where we look specifically at a site or a location or a data center facility up to really scaling out. And I think this is key. And again, I think what's holding potential users of liquid cooling now holding back is their readiness and the level of being prepared for another way of cooling, where probably there's more of a crossover between IT and facility as well. And again, if users are already on immersion cooling, we help them going from an environment that's in operation to an optimal environment. And so we see that more as a thermal management support. I think the benefits of immersion cooling are quite clear potentially, but there's also expertise required. And this is, we see that as a know-how transfer from us to a user, where we help them building this operation that meets actually those expectations that have been set. And that could be KPIs on sustainability, could be performance or a combination. This is really user specific, but we really think that there's a lot of room for optimization to get there, and we're happy to support that. Yeah, and I think I would like to close off this talk, and I think we're just right in time, if I'm correct. So I think there's an opportunity again to look at data centers a little bit different compared to what we see as environments where facilities just being adapted for liquid or immersion cooling. And again, I would like to point out some research we do on an annual basis with Omdia, our partner for market research. We look into annually in drivers and barriers and needs for immersion cooling. And one interesting bit we see is that liquid cooling users are looking into new locations, new sites, new data centers, greenfield, to apply liquid cooling. And when we know this, which is great, by the way, because then all of the potential benefits for immersion cooling can be applied, right? And but if we know that, then there's also a huge opportunity to look at greenfield data centers, slightly different than what we're used to. And according to as well the analysts from Omdia, there's a different approach to applying liquid cooling versus traditional cooling, where liquid cooling starts with what's the workload, what's the application, and then you select your advanced cooling method based on that, and based on that you design the facility. And I think that's a very interesting perspective. It's practically the other way around of what we would see in an existing facility. This is a great opportunity. I think there's an opportunity to develop and design purpose-built liquid-cooled data centers, where in all transparency, I think the reality is that we will see a hybrid or a mix of advanced cooling methods in one facility, but on liquid cooling based. And that brings in a little bit more complexity. It's more heterogeneous kind of environment. But on the long term, I think that's going to be a very interesting opportunity to look at that as an industry. And you see also some visuals on how different it can look. We don't need any elements in the room anymore for airflow, containment. It's all about the system itself. The environment cannot impact the system anymore. It's just the connections, especially, of course, the water supply, that is impacting the performance, but the room itself, not anymore. So there's a very different kind of way of looking at data centers, also in the existing buildings. So I just want to drop this here to inspire everyone and see if we look at greenfield opportunities, we can look at purpose-built liquid-cooled data centers. And to point out one platform where this is also being explored and worked on is Open Compute. I think that's a great platform. Most of our users are looking into what OSP is doing in terms of standardization and guidelines for liquid cooling. I can recommend everyone to look into that. And I think we'll see a lot more of that in the next few years too. Yeah, again, to close, Asperitas, we are here to help. We have a very scientific-driven kind of approach where we like to use test materials and data available, validate everything, work on cases. So I think that's a very important element, because what we see that is users want a reliable and predictable environment. So it starts with selecting the right KPIs, testing according them, providing a benchmark, and then optimizing. We think that the user element for immersion cooling is very important. Again, it's new for most users. Yeah, we think that needs to be taken into account. We need to be able to support users in being prepared, training themselves and their partners, for example. And we love to talk about sustainability. It's really our mission to enable sustainable growth of data centers. So happy to brainstorm with like-minded people. And I think last but not least, especially for this, I think there's a great opportunity to work together to achieve those sustainable data centers and high performance in the next few years. I think there's a lot of innovation available, a lot of know-how, a lot of great minds in this industry. Let's combine them and work on the same mission. So having that said, Kelly, I think it's right on time, I hope.
Yes, so, yeah. Perfect. Thank you so much, Maikel. That was great. Thank you for joining us today. We really appreciate you taking the time to go through that with us. Thank you.
No problem. Yeah, my pleasure.
Bye-bye.